type of computational system that works completely on how linguistics work. And it uses letters, sounds, words, patterns, and it has its own memory and structure. And it's supposed to work like unary. And it has atomic units of computation. A phoneme letter is a token. Features are vowel consonants, fricatives, liquids, front and back nasal. And there's chunks, concatenation, phrases, operations. And here's an example tree: clause, subject, predicate, verb, object. And there's operations of computation such as concatenation, transformation, reduplication. And for example, 1 is ta, 2 is ta, 3 is ta. That's how numbers are shown on this. And for matching control and flow, there's match, pattern, rewrite, rule, conditional branching, and memory structures, glyph tapes, tree store, feature matrix. This is how it works. Simulating computation. For every rewrite or merge, one computational step loop exists in recurring patterns of repetitive rewrites. Conditional logic is implemented via pattern matching, not Boolean numbers. Quantities are represented in reduplication of nested structures. Apply reduplicate, apply delete rule, decrements it. Simulate counting from 1 to 5 using token of your choice, reduplicate rule. And here's some stuff regarding trees, patterns, repetition. Here's your practice problems. Assign features to tokens C, D, E, F, and create 2 chunks. Merge your chunks in a phrase tree and label the nodes. Create a reduplication sequence representing 1 to 4 using your token of choice. Rewrite the rule transforms X followed by a vowel of the new token Y. And here's chapter 2. We learned how to do letters, tokens, features, and sequences in trees. We also saw how rewrite rules and merges reduplication allows computational steps. So now we simulate logical reasoning using linguistic patterns. Match is subject plus verb. Write a rule to match. I know, but this system works like this. It's gonna be
That's not. God damn it! Fucking hell! It's not like that.
I'm teaching a class. I'm teaching a class right now, bro. Conditional branching is executed when a pattern is found or absent. If match XY, then merge XYZ. Else apply rewrite X to X prime. If the pattern X exists, merge with Z. Otherwise, transfer X to X prime. Create a rule that merges any constant followed by a value in the trunk called CV. Instead of numerical loops, we use reoccurring patterns. Apply rewrite or merge until no more exists. Rewrite A, repeat until sequence reaches desired length. Each repetition represents iteration similar to while loop. Simulate counting 1 to 4 using token ta to reduplicate rule. Features allow information to flow from structure. Verb on feature exists, then write stem plus s. Branching without numbers. Traditional computers use 0 or 1. In linguistic computation, branching depends on pattern exists. Yes, apply merge, rewrite, or inflect. No, apply alternative, rewrite, or wait. Match verb. If yes, inflect verb with tense. If no, rewrite X to Y. Write a conditional rule. If vowel appears at the start of the sequence, merge it to the next consonant, otherwise leave it alone. Treat nest operations, simulating recursion. Merge subject, verb, predicate. Merge predicate, object, clause. Rules can operate inside phrases, then propagate upwards. Repeated application, recursive computation. Create a 3-level 3 root clause. Children, subject, predicate, object, apply a feature, agree, operation from leaves to root, token, TA, count 1 to 3, replicate ta. Each step uses pattern sequence to decide what rule to apply. No numbers are used. Counting is purely structural and sequential. Use a rule that moves a consonant at the end of the chunk and start if preceded by a vowel. Simulate a loop, reduplicates token ka 3 times. Create a phrase tree or subject plus verb object. Propagate a future tense for the verb all nodes. Write a conditional rewrite if sequence begins with vowel X and append Y. Use pattern logic, design yes or no decision. If A, B exists, mark yes, else mark no. Control structures in linguistic computation rely on pattern matching, rewrite rules, and feature propagation. And that's all for that. And read some of this extended Chapter 1 Foundation of Linguistic Mathematics. Concatenation is addition, deletion is subtraction, repetition is multiplication, substitution is algebra, pattern matching rules equals logic gates. Just like binary, these rules are enough to simulate like a computer. Create your own substitution rule and apply it to ABB and all of that. Chapter 3, Programming in Linguistic Mathematics. Now that we understand letters as using concatenation substitution rules, we can write programs entirely in letters and read some of this. We already went through a lot of this.